Good morning everyone. Today we're going to have a little experiment about what happens to large sections of timber when you burn them. Here's my son Alexander and I, and we're in my backyard, and I have here some large sections of timber. First of all, we've got a 180 by 90 pine. This is effectively just sections of pine framing glued together with a cross-link PVA. So there is some indentations in the side from where it's been dressed, but we'll see what that will do later on to our cut section after we burn them. We also have then a 180 by 120 section of local hardwoods. So this is a fairly pale material, it's relatively light, but it's a hardwood section. Again, they've just been glued up using cross-link PVA. So our little experiment today is that we're going to light the fire. We're going to put these in so that they hang over the fire. We're going to burn this end of the piece. We're going to keep the fire going until we get a very good char around the outside of the piece, probably in this half and this end, and then later on we'll take it back to the workshop and we'll slice through the wood to see the various layers, the char layer, the pyrolysis layer underneath that, and then the wood in the middle. So at the moment it's about midday, and from here we'll start to light the fire and put the wood in it. Al, would you like to start with the fire?
Yes.
So as we can see, the fire is caught on really quickly. We've got lots of kindling under there and paper. It's all very dry, and the fire is burning around the outside of our glulam pieces. And we're going to keep this stoked up with wood to let it burn for about 20 minutes either side. Okay, the fire's been burning now pretty solidly for a little over 15 minutes. So what we're going to do is we're going to rotate the elements. We're going to put the bottom one to the top and flip it over, and the top one to the bottom and flip it over. Okay, the timber elements now have been in the fire for 45 minutes. They've been turned once in both rotation and around and up, replaced up and down. So what we're going to do now is we're going to take them off, we're going to spray them with water, we'll take them to the workshop, and then we'll slice them through to see what the wood looks like inside. Beautiful, beautiful.
It's like in the textbooks they do.
Just like in the textbooks. So what we have here is we've got this outside char layer that comes from the fire. There's directly underneath that char layer through here, we've got a layer of a pyrolysis layer. That's where the heat has caused the wood to start to biodegrade, and we can see that by this grey colour, and it would progress some way in. And then in the centre we still have the original wood from the material, and it's been protected from the fire by the char layer and the thermal resistance of the wood that doesn't let the heat get into the middle and start to break the wood down. So when we design for fire resistance, we're relying on the speed with which the fire can move through the wood, and that's directly related to the density of the material. So this was a local hardwood, and the next piece is a pine. So again, if we look at the pine, which was a thinner piece and also a less dense piece, We've got the severe charring around the outside, and that would have depended upon when we turned the piece over the fire burning. We've got then a pyrolysis layer through here where the wood is partially degraded, and then we've got the normal wood there in the centre. Ooh, delightful.